Hello, my name is Danny, and this is my periodic alternate assignment for my chemistry course at MUN, Memorial University of Newfoundland in Canada. Okay, so let's get right into it. Here we have a periodic table, and well, this periodic table was actually is from one of my tests, but it's really okay for me to do that because, well, I paid for the course. It's my test. The test was returned to students. So really, this is my property. So I don't really have to worry about that. And so it's kind of nice sometimes to look at an actual periodic table that is going to be given on tests or whatever, so that you know exactly what it is. And if you look at around the periodic table, or even on the periodic table, I've added stuff and we're going to talk about that. And around the periodic table, I've included a lot of information, and we're going to talk about that in just 1 second. So, okay. So I have my laser pointer. So here's my laser pointer. I hope you can see it. And so please, if you can, try to follow my laser pointer because I think it's very helpful. Okay. So the first thing that I want to talk about is right up here, atomic radii. So if we look at the periodic table and we see how the atomic radii is that when it's if you look at the periodic table, if you're at the bottom of it, it's very large, and then as you go up the periodic table in that direction, the atomic radii get smaller and smaller. So if you look at the atomic radii from the other point of view, right up here, and you go from left to right, on the far left, the atomic radii is largest, and then as you go right, it gets smaller and smaller. So that is the trend for atomic radii. So now let's look at ionic radii. Well, this one here is a little different, where if we look at the left part of the periodic table, we see that the cation ions start large, and as you go to the right, they get smaller and smaller and smaller. And if you look at the anions, as they start large, and as you go to the right, they get smaller and smaller, right? So if you look at the periodic table, the cations, so the group, it's pretty much around group 1, where the cations are small, or sorry, are large, and then it ends at around just want to make sure that my pointer's working here. And the cations get smaller and smaller until around here, right? So around like the zinc, the cadmium, right? And then, as I said, the anions, if we take a closer look, they're large at around like the boron, the aluminum, right? And that group. And then they get smaller and smaller as you go far right, where there's argon and krypton and so forth. So if we look at Ionic Radii of the periodic table in the direction of up or down, right? So the thing why this is a little different is that for the vertical measurement, both the cations and the anions behave exactly similarly, right? So if you start at the bottom of the periodic table, their Ionic radii are both largest, and then as you go up the periodic table, it gets smaller and smaller. So next we're going to look at electron affinity, right? So if we look at electron affinity, if we start at the top of the periodic table and then we go downward, we see that at the top the electron affinity is highest, and as we go down the periodic table it gets smaller and smaller, right? So if we look at electron affinity for the other direction, meaning from the horizontal perspective, we see that at the far right of the periodic table, the electron affinity is at its highest, and as we move more and more left, it gets smaller and smaller. So let's talk about ionization energy. So with ionization energy, if we look at the periodic table and we start at the top, the ionization energy is at its highest, and as we go down, it gets smaller. The ionization energy gets lower and lower. So if we look at the periodic table from the horizontal point of view, we see that at the far right of the periodic table, the ionization energy is at its highest, and as we move left, the ionization energy gets smaller and smaller. So next let's look at electronegativity. So electronegativity. So with electronegativity, if we look at the periodic table from the top, and at the top of the periodic table, the electronegativity is at its highest. And if we go down the periodic table, the electronegativity lowers more and more. So so the electronegativity like I said, at the top of the periodic table is at its largest, and as you go down, it gets smaller. The electronegativity gets lower and lower. So if we look at the electronegativity from the horizontal point of view of the periodic table, then if we start at the far right, the electronegativity is at its highest, and as we move left, the electronegativity gets lower and lower. Okay. So next, I would like to discuss what I like to call patterns. Okay? So the thing is that when you're writing an actual test and or exam, you will probably be given a periodic table such as this one, but you're only going to be given the periodic table. And so you're going to need to, as you write the test and or exam, there's a lot of calculations and stuff that you're going to have to know about the different elements or so forth, right? And it's really not possible, or it's going to be very, very hard for you to memorize all of it. So what you've got to do is that kind of one of the big basic points of the periodic table is that just by looking at it, there's so many different things or hints about it that can just tell you just information that in which you can just know just by looking at the periodic table without necessarily memorizing it. So let's first go over a little bit of the basics, like groups and periods, right? So a group, I just want to make sure my pointer's working. So the groups are kind of go from left to right, right? So that means like here, because like I said, this is an actual periodic table that was given on tests, right? So you're going to be given all of these numbers, right? And these numbers at the top where my pointer is. And so what you call that is, for example, this is group 1, like all down that column. And then this is group 2, group 3, and so forth, right? And that's how we refer to them in chemistry. And then, so they're basically the columns. And then you have what we call periods, right? So periods are basically rows, right? So you have like, here would be one row, right? If you look at my laser pointer, and see it kind of like on the top, if you can see follow my laser pointer, that would be another row, and that's what we call periods, right? Now, the other thing that I wanted to talk about that you really need to know is metals, non-metals, and metalloids, right? So as I've already indicated here, the metals, I've just sort of colored them in yellow, right? So the metals, if you just look at a periodic table, you can automatically tell that this whole yellow section, everything that's in yellow is the metals, right? And then the non-metals, I just colored it in green, right? So for me, all the stuff that's in green. So those are all the non-metals. And we also have another category, and we call those in chemistry metalloids. Now metalloids are basically they have like both properties of both metals and non-metals, or they're in between, right? So for me, if you can always basically tell them just by looking at periodic table, really. Well, I've colored them in purple, so you can see here we have this one here, 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 and this one here. So those are the metalloids, okay? And most periodic tables, including this one, will have sort of a very darkened, bold line that goes through. And so that's another kind of helpful tool, right? And one of the other things that I also included is the noble gases, right? So I've included, the reason that I included the noble gases in particular for this topic is that when you're kind of studying topics such as what we talked about, like ionization energy and electron affinity, for example, those topics are going to repeatedly go back to the idea or go back to the noble gases. So you not only have to know what the noble gases are, but you have to sort of understand them, right? And so I've shown you here what the noble gases are, right? So the noble gases are helium, neon, argon, krypton, xenon, and radon, right? And that's why I call it a pattern, right? Because it's basically, they're all just one column. So very easy to remember, right? Just like the metals and non-metals, right? Whereas the metals are all on the left, non-metals are all on the right, and the metalloids are sort of in the middle. So you see these patterns, right? And the other thing is on this periodic table, the blocks are already given, right? So here, you see my pointer, that's the S block, right? And then the D block, right? So the S block, the D block, the P block, and then the F block, right? And so like I said, on my periodic table, that's already given. And so next, what I wanted to mention was in chemistry, we use monatomic ions a lot. A monatomic ion is an ion formed from a single atom. It's very difficult to memorize all of them, but if we look at the periodic table, we can see patterns, right? So here, if we look at the mnemonic ions for, like I said before, we would call this group 1, right? So group 1 is this whole column, right? And if we look at all these monatomic ions, they all have the same charge, right? Li plus, Na plus, potassium plus, rubidium plus, cesium plus, right? So the pattern, or the easy way to remember it is that this is group 1. Remember, these numbers are given on my periodic table either, right? And so because it's group 1, all of these have a charge of +1, right? So if we look at group 2, it's very similar, right? So group 2, so all of these have a charge of 2+, right? And so use exact same I like to use the exact same way to memorize it. Group 2 means all of these have a charge of 2+, right? And so here we have something else where there's another pattern, right? So in group 16, we see that oxygen has a charge of 2-, sulfur has a charge of 2-, selenium has a charge of 2-, tellurium has a charge of 2-. They all of these have a charge of 2-, right? And the way I like to memorize it, where I kind of see a pattern, is if you notice that the last group is group 18, right? So what I do is that these are all in group 16. So what you do is you go 16 minus 18, and then you have -2, and these are all -2, right? Very easy to remember because you just have to think of that last column, which is 18, and you do the exact same thing for the one right next to it, which is group 17, right? If you look at fluorine has a charge of -1, chlorine has a charge of -1, bromine has a charge of -1, iodine has a charge of -1, right? They all have -1, and they're all in group 17, and you do the exact same kind of math. You go 17 minus the group number of the last one, which is 18. So 17 minus 18 is -1, and these are all -1, right? So you just, again, like, periodic table is all about, you know, seeing properties and trends and patterns, right, that you can find out by your professor or books, or just through experience of, you know, working on it on your own. You can find your own patterns, right? And I think that's about it. I just don't want to finish. I just don't want to stop the video and then find out that I forgot something later on. Yep, I think I got everything. I don't think I forgot anything. So I'm just going to wrap this up and say thanks a lot for watching, and press the subscribe button and press the all notifications button so that you'll know whenever I post a new video. Goodbye.